In this video, you will learn how to solve problems using the properties or laws or rules of exponents. Now let's solve some problems here. Use the properties of exponents to determine the value of a for the equation. So we're given this equation here and we just need to solve for the value of a. Alright, since we are to use the properties of exponents, then we need to convert everything in exponential form. Now we only have square root of x here in its root form, though we convert this to exponential form. So square root of x, that means the index here is 2, so we can rewrite this as x to the 1/2. I meant the radical form, we write this in exponential form. So square root of x is just equivalent to x to the 1/2. So our equation would become x to the 6 over x to the 1/2 equals x to the a. Now notice here that all of the bases of each of the expressions, they are all x equal to x, which means the bases are all the same, so we can apply the properties of exponents or the rules or laws of exponents. So in this case here, that one is a division, so we can apply the quotient rule. So when the terms with the same basis, we can just subtract their exponents. So this one would become x to the 6 minus 1/2. So we subtract the exponent of the denominator from the exponent of the numerator, and then we equate this to x to the a. Alright, so we subtract 6 and 1/2. So 6 minus 1/2. Make sure you know how to subtract a whole number and a fraction. So you just have to get the LCD of this one. LCD is 2. Since 6 is a whole number, so the denominator of this is considered as 1. So 2 divided by 1 is 2. 2 times 6 is 12. 2 divided by 2 is 1. Times 1 is 1. Then we copy the operator sign minus, so that is 12 minus 1, which is 11. So this is just 11 over 2. So this is x to the 11 over 2 equals x today. Alright, so now how are we going to solve for a? Again, the bases on both sides are the same and they are equal to x. Then we can apply the property of equality for exponential equations, which says that when the bases on both sides of an exponential equation are equal, then the exponents must also be equal. So we can just equate the exponents. Therefore, 11 over 2 is just equal to a. So the value of a here is 11 over 2, or we can write this in its mixed form, mixed fraction form. So a is just equal to 5 and 1/2, or 11 over 2. Now let's solve another problem. Alright, let's say we're given this equation here. Now we need to solve for or determine the value of a using the properties of exponents. So we have x to the 1/3 to the power of 4 cube root of x to the 4th equals x to the a. Again, since we're going to apply properties of exponents, then we can rewrite everything in its from its radical form to its exponential form. So we have here cube root of x to the 4th. Okay, the index is 3. and the radicand is x to the fourth. So we can rewrite this as x to the fourth to the 1/3 as its exponential form. So this is 1/3. Now we can write our equation as x to the 1/3 to the fourth, this one, and then this one, which we've rewritten as x to the fourth to the 1/3 equals x to the a. And then we can simplify the exponents. We can apply the power to power rule here. We just multiply the exponents. So this is x to the 1/3 times 4. So 1/3 times 4, that is just 4/3 times x to the 4 times 4 to the 1/3. So 4 times 1/3 is also x to the 4/3 equals x to the a. And again, take note that the bases on both sides are the same, and we have multiplication here, so we can apply product rule. So we just have to add the exponents. So this would become x to the 4/3 plus 4/3 equals x to the a. And then we can equate the exponents as 4/3 or 4/3 plus 4/3 equals a. And now we can simplify. We add 4/3 plus 4/3. Since the two fractions have the same denominators, then we can just simply add the numerators. So 4 plus 4 is 8. So this would become 8/3 equals a. So that is the value of a. Or we can rewrite or write a as a mixed fraction. So this is just 2 and 2/3 or 8/3. So that is the value of a. Now let's solve another problem. Alright, let's say we're given this problem here. This equation, x to the 5th to the 1/2 over square root of x equals x to the a. And then we solve for the value of a. Again, we rewrite everything in radical form into its exponential form. So we only have square root of x here. Then we can write that in its exponential form as x to the 1/2. Since this is square root, and the index is just equal to 2. And our equation would become x to the 5th to the 1/2 over x to the 1/2 equals x to the a. And then by power to power rule, we can multiply the exponents. This would become x to the 5 times 1/2 is 5/2 over x to the 1/2 equals x to the a. And we can apply the division rule for that one. So our equation would become x to the 5/2 minus 1/2 equals x to the a. Since all the terms have the same basis. So for division rule, we just have to subtract the exponents of the numerator and denominator. Since the bases of both sides of the equation are the same, then we can apply the property of equality for exponential equations. So this would become 5/2 minus 1/2 equals a. And 5/2 minus 1/2 is just equal to 4/2. Because the two fractions have the same denominator, so we can just simply directly subtract the numerators. So that would become 5 minus 1, which is 4. So this is 4/2 equals a, or a is just equal to 2. So to solve equations like this, using the properties of exponents, you just have to familiarize yourself all of the rules or laws or properties of exponents: the product rule, quotient rule, power of a power rule, power of a product rule, power of a quotient rule, zero exponential rule, negative exponent rule, fractional exponent rule. And you can also apply the property of equality for exponential equations, where when the two bases, or when the bases of both sides of the equation are the same, then you just have to equate the exponents.